In this question, we're gonna try to prove this theoretical question. So we assume that f is continuous on some a in R, okay? And we want to prove that the absolute value of f is also continuous on R. So the key idea here is that the we are given that f is continuous on A. So how can we get from here to here? So the best way to deal with this kind of questions is to write the definition. What do we mean? Where we want to go? Okay. So f is continuous on A. That means we can write it in terms of the quantifier is. So for every epsilon positive, we can find some delta positive such that x minus a is less than delta. This would imply that f of x minus f of a is less than epsilon. Okay, so this is the meaning of f continuous on A in R. Okay, we can do it graphically, but that's not the aim here. So we want to use the epsilon delta definition to write this one in using quantifiers. Okay, so the issue is, what about this? So we need to show that the absolute value of f of x minus f of a is less than some epsilon prime or epsilon, the same one. It doesn't matter. Okay, so this is our aim here. Okay, if we write the definition here, if we complete these ones here, we can say that for every epsilon prime there exists some delta prime or the same delta such that x minus a less than delta. Would this imply that we have this? Okay, but we know that we can take the epsilon be the same thing because it doesn't matter, and for the delta we will take the same one. Okay, because here we have x minus a is less than delta. Okay, so we're not going to switch. So x is continuous on a means that as we get close to a with a certain distance, what happens to the absolute value of f? Okay, so the key idea here is to use the triangular inequality in somehow. So we know that x, the absolute value of x minus the absolute value of y in absolute value is less than x minus y. I've proved this one in one of the videos, but here x is not in R, so I have proved this one for the case when x and y are in R. So but here we want to prove it for functions. We want to prove that f of x minus g of x, okay, less than f of x minus g of x. Okay, but we can prove it. Okay, so here, so x is in R, but f is some continuous function on some interval a, b, f and g. Okay, so as we say here, as x gets close to a, here we can say as f gets close to g, but that's not the issue now. So we're going to use this fact here. We are not going to prove it now, but we're going to use it. So here we know that given this first one, we know that for every epsilon positive, there is a delta positive such that x minus a less than delta will help us get, or this will imply that f of x minus f of a is less than epsilon. So given these conditions, okay, but we know that this is bigger than f of x in absolute value minus g of x in absolute value, everything in absolute value, less than f of x minus g of x. Okay, less than epsilon. Okay, so if we take, in our case, if we take g of x as f of a, we will have f of x minus f of a. So don't forget the absolute value is less than f of x minus f of a. But this one, we're given that it's less than epsilon. Okay, so therefore we have f of x in absolute value minus f of a in absolute value. Everything in absolute value is less than epsilon for the same epsilon and the same delta. Therefore, for every epsilon positive, we can find a delta positive such that x minus a less than delta would imply that f of x minus f of a less than epsilon. This means that f, the absolute value of f of x, is continuous as a. Okay? This means that that's the definition. Okay? So remember here to choose carefully which function that you have, and these inequalities. Okay? We need to prove this. There is a video on this, but if you know how to do this, you will be able to do this one as well. Okay, so this is a must. So this is a must-have in your hand when dealing with some theoretical questions like this. Okay, if we'll prove this one later. Okay, so when we are dealing with functions, I'm gonna add this one. Maybe on Sunday we will have a video on this. I have proved this one. You can find it. It's on one of these videos. So this is for the case when x and y are just numbers. So this is for the case when f and g are functions of continuous functions on some interval a, b. Thank you. If you see any mistakes or any errors, please comment or contact us. Thank you.